This Week in Radio Tech, episode 309, is brought to you by Axia and the family of Axia Xnodes. Xnodes connect traditional analog and AES audio gear to AOIP networks. By the Omnia 11 FM HD audio processor. Get $500 off an Omnia 11 now and a free upgrade to the GeForce Dynamics engine. And by Lawo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. When broadcasters swapped their cart machines and turntables for PC-based digital playout systems, we now call that virtualization. Michael Dosch with Lawo joins Chris Tobin and me to describe how dematerialization or virtualization is the future of content creation and broadcast workflow.
Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. Delighted that you're here. This is the show where we talk about everything from the microphone to the light bulb at the top of the tower, and nowadays it's a lot of stuff in between. A lot of that stuff is getting pretty fancy, but in ways it's making our jobs easier, and that's part of what we're going to talk about today. Our show is brought to you by some great sponsors, and I do wish that you would check them out, patronize them. If you can. Don't patronize them, patronize them. And those include Axia, also Omnia, and Lawo. Plus, we might have another sponsor coming on the show within the next few weeks, so excited about that too. Hey, so I'm Kirk Harnack. I'm at my office in Nashville, Tennessee. For disclaimer purposes, I do work for the folks at the Telos Alliance, and sometimes I'm biased toward stuff that they do make and propose. So we know that right up front. Now we have another biased individual to bring on the show, and that's my co-host in the New York City area. It's Chris Tobin. Hello there, Mr. Biased. How are you?
I am so biased. Just for full disclosure, I am not employed by any of our clients, our commercial or sponsorships, or anything that's involved in making this product or this netcast possible. But other than that, I'm very biased about everything.
I think it's a good. When I ask you a question, I always get an answer, and it's usually a pretty sure answer, and that means you must have some kind of bias toward, I don't know, using technology well.
Well, it's a crazy thought. You're going to spend some money on technology, have a workflow, and at the end of the day, you're trying to make some money. You might as well do it correctly so you can have fun, make money, and enjoy life. I don't know. It's the three things I enjoy trying to accomplish. And if you find that to be a biased or negative approach to a question, then so be it. As I would say to some people, go pound sand.
Okay. Whoa.
But I'm not biased.
All right. No, you're not biased at all. I'm a New Yorker. How can I be biased? So our guest this week is somebody who Chris and I both were privileged to sit in on a presentation that our guest made a few months ago at the Public Radio Engineering Conference. And we were pretty mesmerized and enthused by this presentation, I got to say. I think Chris Tobin took a lot of notes. I was thinking of all the things that I should have said during my presentation that our guest said, but he did it very well. So let's bring on our guest. It's Michael Catfish Dosch, and Mike is with Lawo. Hey, Mike, welcome in.
Hey, Kirk. Hi, Chris. How are you guys doing today?
We're good. We're good. And how are you?
Yeah. Sorry, Chris. I'm doing well, and I'm biased also. So I'm with Lawo, and that's one of your sponsors, and I actually kind of like the stuff that Lawo does. So, full disclosure.
That's a good bias.
Chris, you were about to say something. I'm sorry. Go ahead.
No, I'm just saying it's good to be biased. And on this show, we got several people that are biased for many reasons. It's good. It's good conversation.
Absolutely. Well, when you know a lot, sometimes the more you know about something, the less sure you are because you know all the possibilities. But if you know enough to know what you're doing and kind of do it right, then sure, it's good to be biased. So shall we call you Mike, Michael, or Catfish?
Well, my friends call me Catfish, so you can call me Mr. Dosch, Kirk. Please call me Catfish.
So, Catfish, we're going to break for commercial here real quick, but give us a little wet our whistle, if you will, for what we're going to be talking about, this notion of radio virtualization. I'm not sure I know what that means, so kind of give us the elevator speech that makes us want to listen through the commercial.
Okay, sure I will. Everybody these days is talking about putting everything in the cloud. And, usually we chuckle, those of us who are technical, we kind of chuckle when our managers come to us and say, why aren't we putting everything in the cloud? But there is a trend in the IT area especially for more and more applications, software being moved into cloud infrastructure. And so one of the questions that a lot of our clients are asking us is, well, can we do this with radio? And the answer is yes, with a series of caveats, and that's what we're going to talk about. We're going to talk about what is involved to migrate the way we do radio today, radio studios in particular, but we can also talk about distribution. What is involved in migrating this into an IT infrastructure that you know, the vernacular is the cloud. So that's it in a nutshell.
I am interested to hear what that entails and how that works out, because you brought up some very intriguing subjects and scenarios in your talk at the PREC. Hey, I want to tell you that our show is brought to you in part by the folks at Axia. And this week, our show is brought to you by the Axia Xnode, the entire family of Xnodes. And there's the webpage right there. You go to either axiaaudio.com or telosalliance.com and click on Axia, and you'll find the nodes. Now, let me show you. If you return the camera back to me there, Suncast, everybody's familiar with these things, right? You know where these go, right? They go to, gazintas and gazoutas from your equipment. Pretty common connector, the XLR. What does that XLR need to connect to in today's modern environment? Well, oftentimes it goes through an adapter, and that adapter ends up going into an RJ, there we go, an RJ45 connector. Now, where does that RJ connector go? By the way, that's used because it's convenient, it's easy, it's gold-plated, and it just doesn't seem to fail. Well, that connector can go into the back of something like this. This is an Xnode. This is the back end of an Xnode. You see it's got a power connection there. It's also got two Ethernet connections. One of them is PoE, so you can power this node from an external power supply. So you got dual power supply, one internal and one external. And then it's got RJ45 connectors for the inputs and the outputs. Okay, what does the node do? What is the purpose of this? Well, the purpose of this is to connect equipment to an AOIP environment, audio over IP, whether it's Livewire, Ravenna, AES67. It connects that equipment, like speakers or amplifiers or microphones, anything that is not new enough to have its own IP. This is the box that hooks those together. And this form factor, it's just awesome. It's rack mountable. You can put two of them side by side in a rack if you like. This particular one I'm showing you is the analog I/O. So it's got 4 stereo analog ins and 4 stereo analog outs. But here's one that a lot of folks are finding very useful in their installations. This is what we call a combo or a mixed signal node. This one actually has a mic pre built into it. Yeah, right there. Mic pre. It's really high quality, sounds fantastic. It's also got analog and even one AES input and output. Plus it has some GPIO built in right there. So you got some contact closures in and out. And as usual, the 2 network connections, and one of them PoE, and the power connection there too. That's the mixed signal node. So we're going to introduce the whole family here real quickly. This is a GPIO node. So let's say you've got a rack of satellite receivers and you're taking contact closures from those satellite receivers. This is the node that you use. You take those contact closures from the satellite receiver, you wire them into here, and then these contact closures are available anywhere on your network, including your automation system. So your automation can be looking for that closure from the satellite network to start the next stop set. And finally, I want to show you something. I've got an AES node. We have an AES in and out node. That's over here in my rack. It's got the lights going. You can barely see it off camera there. And then here's one that's really intriguing. If you're a television shop, this is SDI in and out. It's got 2 ins and outs. So you can run SDI in. It will delay your video by how much you want it to. It'll break out 8 channels of audio and let you move those around if you like, or export them somewhere else on the network for audio processing, and then bring them back in and re-embed them in whatever order that you like. So there's a lot of utility that you can get from this SDI node, and it's just, again, amazing. Good stuff there. Dual power supply also, external and internal. So Axia Xnode's the way to get stuff in and out of your Axia system when you've got devices to add that don't have their own audio over IP. Thanks a lot to Axia for sponsoring this portion of This Week in Radio Tech. All right, we're talking with Chris Tobin is on the line with us, and Mike Dosch, Catfish from Lawo. Okay, Mike, at the PREC, you really intrigued us with this notion of virtual radio. Where would you like to start with explaining what this is? Well,
let's talk about software, and In fact, let's even back up from software and talk about a term that we've been calling dematerialization. We didn't invent this term; we picked it up somewhere. But it's a great term that describes what's happening these days with your smartphone. If you recall, you probably used to at some point. At least I did, because I'm an old guy. I used to have a briefcase full of junk that I carried to work with me every day. Calculators, and I think I had a Rolodex or something like that. And I had a Franklin day timer, and a wristwatch, and lots of stuff. And this stuff has all gone away. It's been dematerialized. It's become software. They've become software apps that run on our smartphones. And so we're very familiar with this. I mean, a bag phone becomes an application running on our smartphone. A day timer becomes an application running on our smartphone. And of course, it gets kind of exotic from there. I mean, we watch TV on our smartphones. We listen to radio on our smartphones via the internet. I guess there are some smartphones that have FM receivers, but we'll set that aside for the moment. In any case, all of these applications are replacing some kind of hardware thing, or some kind of physical thing. And so this is the term that we refer to as dematerialization. And what needs to happen in order for us to imagine a cloud infrastructure is we have to dematerialize those physical aspects of the radio studio. It actually makes sense if you think about it. You're not going to float a piece of rat gear in the cloud. It needs to be a piece of software. And once it's a piece of software, then it can run on a PC. And a PC is the precursor to servers that are running in the cloud. So if you think of something like Amazon Web Services, for example, it's a server farm. And it's a server farm running Intel servers, thousands of them. And, if an app can run on a PC, then it can run in a server farm within a virtual machine environment. We'll talk about that a little bit more. But this idea of dematerialization is really important. And one of the questions that people ask us is, well, how could we do radio in the cloud? Well, the first answer to that is everything has to be software. It has to be software. And then once it's software, then we can start imagining different architectures. So we start there. If you think about a software application to replace broadcast boxes, there are a lot of devices that we use in a broadcast plant. We have mixing consoles. We have sound cards and PCs. Although it's not really a box per se, it's a piece of dedicated hardware that has a function. We have codecs, broadcast codecs. We have phone systems. We have streaming encoders. We have audio processors. And so all of these devices, these rack mount hardware devices, these can be replaced by software applications. And when they are replaced by software applications running on commodity hardware, the world gets a lot more interesting. I have to take you back, Kurt, because you, of all people, remember this. When we were working together at Axia, launching audio over IP, it was kind of a lonely mission back then. I used to tease you. I used to say, Kirk, I know you'll go and talk to anybody about AOIP, and if they fog a mirror, you'll speak to them for an hour about the benefits of IP audio.
I was an early believer, man. I read Steve Church's paper on how that would work five times, and the fifth time I read it, I went, oh, this can work. Oh, man.
Exactly. So, and look at us today. I mean, the entire industry has said, okay, this is it. Everything is AOIP now. But what's interesting,
and if I may say one more thing, is at the NAB show last April, so there was the TELUS Alliance booth, and a few booths away was the Lawo booth. And of course, Lawo has a lot of things besides AOIP. They have a lot of other products they make as well. And yet, if you stood in our booth or the Lawo booth and looked anywhere, all you saw was signs for AOIP and AES 67 and other flavors of AOIP. So you couldn't avoid it if you tried.
Yes,
it's everywhere,
and it's a great idea. So credit to Steve Church. God rest his soul. What a brilliant idea, and it's changed the industry. What's interesting about AOIP, though, is that it is a modern replacement for what we've always done. We used to connect our boxes together with analog wires, and then we got sophisticated and we connected them together with AES-3 digital connections. and maybe even MADI connections. And now we use AOIP to connect our boxes together. But we're still connecting boxes together, and we still have functions that are standalone inside of these boxes. And so what I want to introduce is this idea that beyond AOIP, there is a kind of a step 2 that's enabled as a result of the fact that we're working in an IP environment now, and that is to dematerialize. Let's take some of these boxes that perform these functions, turn them into software apps, and run them on commodity hardware, run them on the PC. So that's really kind of the idea that we want to talk about.
If I could make an analogy, we're already doing some of that with automation systems, right? Because we used to have turntables and records and cart machines and carts and CD players, and then some of us had some kind of digital playouts before a full-blown automation. And we had a paper log and a person to interpret the paper log into the commercials that had to run or the announcements that had to run, and then some kind of formatical thing, whether it was 3x5 cards or an actual wire metal record holder that would hold literally 40 singles, where Top 40 Radio originally came from. I like this phrase, dematerialized all of that into modern automation systems. But you're talking about going another leap in that direction, I believe.
You are exactly right. That's exactly what happened. We dematerialized cart machines, tape machines, LPs. Then we went digital, if you recall. So we brought in CDs, but we didn't get rid of everything else. We just added more modules to our consoles and played CDs, and we even toyed with mini discs and a couple of digital tape formats that we thought were going to be digital cart machine replacements. But ultimately, what replaced all of that source equipment was the computer and audio playout applications. And you might even ask the question, okay, so we replaced everything. I mean, you can't find a radio station now that isn't using computers for audio, recording, playing, and editing. What is interesting, though, is why did we stop? I think this is an interesting question. Why did we stop? We took all of our source equipment and we moved it into the computer, and then we stopped. And we said, okay, that's enough. This far and no farther. Now I'm going to take my computer and feed my console, and I'm still going to use hardware codecs and hardware phone systems and hardware audio processors. And there actually is a technical answer for that. It's an interesting question, and there's a technical answer for it. And that is that in about the year 2000, maybe 1999, somewhere in that time frame, the state of the art in personal computers was a Pentium 4 running about 3 gigahertz. And this machine, although powerful, was really working pretty hard to deliver, let's say, 4 stereo audio streams into your console. It didn't have any leftover headroom. It was working really hard to play audio, basically to be the cart machine replacement. And but something's happened in the meantime, and we know this. We know that here we are 15, 16 years later, and the computers have become a lot more powerful than they were in 2000. I don't think anybody disputes this. So we stopped moving things into the computer because we thought of it as an audio playout device. And also at the time, while that migration was happening, we'd pretty much maxed it out. There wasn't any room to do anything else. In the meantime, it's become 30, 40, 60, 100 times more powerful. And so to do the same job today, the typical PC, which incidentally costs about the same as it did back then, a $2,000 PC today compared to a $2,000 PC in the year 2000 is 100 times more powerful. And we're now in a situation where this computer is just loafing as it delivers those 4 audio streams to your console. So maybe it was at 90% utilization before, or 70, and now it's at 5 or 10% utilization. So the question is, what can we do with that? What can we do with all that latent capacity that we're not using? And I'd like to think that we could do something interesting as opposed to running, Facebook in the studio.
Chris, you were in on the PREC, and I kind of remember this same talk from Catfish about how much more powerful the PC had become. I guess our computers are, our computers at my stations aren't loafing along because we tend to buy 5-year-old Dells that have been refurbished, so they're a little behind the times. But Chris, maybe you've got some more modern computers at your place that are loafing and could do more.
Well, we're doing virtualization on the business machines, and we have a couple of our new services on virtual servers, along with a couple of audio programs. We also have those very powerful little handheld devices that the ARM processors do a lot with, and these are little recording devices for the folks who do music interviews that we have. So, yeah, Catfish is right. The PREC conference, his presentation was spot on about the fact that it's time to rethink how we do the workflow. So, in 2000, the Pentium 4, 3 gig machine, single core was doing exactly what it had to do for the time. And now we fast forward to 2016, and you've got, multiple cores, 3 gig, 3.5 gig, whatever, the in between there. But now the power is, 100 times better. And it's a question of what we think of here, how creative we can be. So, it's a great time to be doing this stuff. And between AOIP and the ability to virtualize almost, I'd say probably 90% of what we do in a radio station, even television, but we'll stick with radio at the moment, you can make it happen. You can do some wild stuff. And think of it, you don't have to be confined to your studio facility to make it happen.
So, Catfish, I would propose, and I bet you're going to answer this as well, that the reason that more stuff hasn't been virtualized isn't only PC power, not having been available back then, but also the connections that the things that we want to do, like a dedicated box that does a talk show. Well, up until recently, we've plugged physical POTS lines or ISDN lines into them. Only recently do we now have the ability to handle all those phone calls over an Ethernet connection. Same for codecs. Typically, those would be over an ISDN connection or maybe even a T1 connection somewhere. So there's these. Our mindset is around boxes that have specific connections on them. Would you say that's also part of why we still have boxes?
I think you're absolutely correct. I think this is the migration of what we do into the IP world, and now that we're doing VoIP for callers. Now that we're doing IP codecs, now that we're doing IP streaming for the delivery of program content, now that we're using IP connections to link together our studio and our transmitter, once we're in this IP environment, then we really have the ability now to do these make these products pure software products. And run them on commodity hardware. But you're absolutely right. I mean, technically, I guess it was possible to take 6 POTS lines and jam them into the back of a PC with a special card. But maybe this isn't so beneficial as what we're talking about now, which is the software-based radio studio.
Now, I don't want to get ahead of the progression that you were going here, but it sounds like you're going to a place where you propose that we put a talk show system in a PC and codecs in a PC, and I don't know what those two things come to mind. Audio processor in a PC, streaming encoder, which we already have that in a PC. What's of course the things that are left are the things that humans touch and deal and talk with, like like a Sennheiser microphone here. How many things are you looking at putting in a PC?
Well, we're not going to put the microphones and the headphones and the speakers into the PC. I mean, we still have transducers that we have to interface with. In fact, you were showing Nodes a little while ago, and that's their mission in life is to convert a microphone into an IP signal, or to convert an IP signal into a speaker feed, for example. So there's always going to be some of that. But the real question I think that we need to ask is, do we need so much of it? And, I can imagine a future where a complete radio studio is really just one I/O device and one IP connection to one PC. And so the I/O device interfaces your microphones, your speakers, your headphones, your audio devices, and then the IP connection to the PC means that those signals get into the PC where they're mixed and processed and sweetened and interfaced with other software apps that are running in there. And when you're all done, then the PC outputs a mix, which is a program feed, and maybe it goes back to that box to be distributed, or maybe it goes to the network to be distributed. So it's greatly simplified as a result of the fact that we've got these applications speaking to each other. Maybe an analogy is, think about all these boxes that are connected together with Ethernet, and now most of them are just connected together by running as software applications on the same PC. You still need a bit of I/O, but maybe you're one node instead of 12 nodes, and this I think is the difference between the way we do it now and the way we could do it with software apps.
Wow. Okay. So, man, this is like it took 5 times reading Steve Church's white paper on AOIP for me to wrap my head around that. You're saying that, okay, we're all used to running an automation on the screen. And I've noticed that the latest commercial copy that your company provided to me is about, hey, your console is easy enough to run. Maybe when you get a little break here, you move the console off the screen and you do other things. And maybe you're foreshadowing these other things. Maybe you're recording a commercial or taking a phone call or setting up a request or a prize winner with a phone system. And that's an app on the computer. Is that where you're going with this?
Yeah, something like this. Let me tell you where this idea really hit me. I had a year off after I left Telos and before I started at Lawo, and in that time I started fiddling around in my basement recording studio, and so I learned how to use some of this modern workstation software. It's called digital audio workstations in the recording industry, and this is exactly how they've been doing business for the last 10 years. So you have programs like Pro Tools or Apple Logic or a few others out there, and the idea is there's some kind of an audio interface to get some number of microphone signals or some number of line signals into the computer. Once it's in the computer, you go ahead and you do your multi-track recording, your multi-track editing, your processing. And what really impressed me was how much processing capability there was inside of this PC environment. And I have to say that I've been a console designer for 25 years. That's what I do. I design consoles with faders, physical on-off switches and knobs and faders and all of that kind of thing. And for the first time, I'm playing with a software-based recording console that's very sophisticated, and I'm really impressed with it. And I'm starting to see that maybe this isn't the way I would have thought of approaching a recording, but now that I'm using it, I'm seeing some of the benefits. Just like this dematerialization idea in the first place. You might not think that your iPhone, an application running on a phone is going to be a perfect substitution for the way you used to do it with a physical thing. But then when you get it in software, you start realizing it is a pretty decent replacement. No, it doesn't have a physical knob on it. However, it integrates with 12 other applications and does interesting things that I never would have thought of before. And so that's really where this hit me. Was I'm playing with a recording studio, and I'm thinking, we still build radio studios very much like pre-21st century recording studios. Back when we had a box for everything. And so it occurred to me during this time that you could conceivably do all of this in software. And then, part 2 of that was I started thinking, we've already, as you said earlier, Kirk, we've already moved audio recording, editing, and playout into the workstation, into the PC. What if we moved the console into the same PC? What if we moved the codec into the same PC, the phone system, even the audio processor? What could we do as a result of having all of these tools available to us inside of the PC? I mean, never mind the fact that we're saving all of the cabling and networking and all the stuff that we have to deal with when we're connecting boxes together. I think that's a benefit, but that's not the one that gets me excited. What gets me really excited is the idea that all of these applications are going to be able to speak to each other. And for example, just to throw an idea out there, what if my audio processor happened to know exactly what I was playing through my console right now? It actually knew the song I was playing, and or maybe it knew that my microphone was open, or it knew that I had a guest on the phone, or it knew that I had a codec remote active. And what if my audio processing was not just designed to take any kind of input all the time and make it sound a particular way, but it had some way to adapt to these inputs? Well, here's a way that we could communicate that. We could actually tell the audio processor what we're up to and allow it to adapt. And, I'm thinking about somebody like Frank Foti. Given that kind of information, he would do very interesting things with it. So this is what I'm thinking about is how do we take these apps and get them to speak to each other and share useful information and take us to the next level.
And boy, it doesn't take even my pea brain can figure out it doesn't take much to take that a step farther. Hey, the audio processor that's in the PC or server or cloud, wherever it may be, now it knows that the source on the air is a codec that's running G722. So it's a lower quality codec audio coming in. How am I going to process that? Or now it's a studio mic, which I happen to know is a Neumann U87 or maybe a Heil PR40. And so the processor knows the characteristics of the source that's on the air. Wow. Doesn't that open up some possibilities?
Yes.
Chris, is your head spinning?
No, my head's not spinning. I can assure you that actually what Catfish is talking about, what we're all talking about, I enjoyed the fact that, and you remember when I took on Axia product way back at another place I worked at, and everybody shot at me, and I was the frontier guy with the arrows in my back. The reason I went after the audio over IP approach, and we did what we did at that facility, a very small radio station, was because prior to that, I worked at a radio network, and I was given a challenge. We had to find a way to come up with a better workflow to produce several country music shows that we had for the network. They were syndication shows. And I was told the budget is X. Here's the room you've been given. Come up with something that these guys can produce shows out of and make it happen. This is 2002, 2003. It's a Pro Tools workstation, part of a Pro Tools network that I built for the other studios to talk to, as Catfish alluded, how you could transfer things around in a production environment, move around, do stuff. And the approach I took was we didn't use a console in that studio, in the control room. It was a Pro Tools workstation on the furniture countertop. There was a router head from the house router that is, and those audio outs went into the motor mix option of a Pro Tools machine. This is when, before all the software-based stuff started coming out. And through Pro Tools, you manage the motor mix, the faders. Those inputs were dedicated. So through our remote software capabilities they were primitive, but they worked. I could have the guys remote to that studio if they had to, produce something from home in the last minute changes that had to be made, and never had a broadcast console in the room, produce the show for 350 radio stations. And this was in 2003. We were doing the workflow that you're talking about now that we could use a PC in. Okay, so when I had the opportunity to do audio over IP with the technology, it was a little more form factor of it. I realized things were going in the right direction. It's just a question of, and I always say this, it's a question of imagination and how you apply the workflow. So even if you have a U87 in the studio, if you don't have the workflow behind it, you can have all the devices talking to it. It won't mean bupkis because you won't get a product that's the result you want. So, my head's not spinning. My head's thinking about other ways I could do stuff because I did it before the computers were available, and it was fun. And that was using a digital audio workstation, Pro Tools, on the Windows platform, not Mac. So it was even more of a challenge. And using the motor mix external device, that was MIDI, too. That was a MIDI controller. So think of it as a MIDI controller, Windows PC running Pro Tools, part of a 6-workstation network producing 300 radio shows for 300 affiliates that had to be done. Started Monday, ready Thursday, up on the satellite by Friday. And we actually had remote access. Limited, but we had remote access to do last-minute changes.
Wow. Catfish?
Very cool. So let's explore a controversial side of this a little bit. This always gets people excited. I think consoles are almost as controversial as audio processors. You want to get a gang of radio engineers excited. Throw out what's your favorite brand of audio processors, and then stand back.
Yeah,
and,
exactly.
Consoles are a little bit less so, but still kind of along those lines. People have strong opinions and strong preferences about what their console should be like. And one of the ideas that attaches to this, it's not necessary, it's not mandatory, but it's enabled by the software application, is we could make software-based consoles. And maybe we use multi-touch as a way to interface with a radio console. And I always enjoy having this conversation with people because about half of them will say, okay, that's a really cool idea. You mean I could interact with my broadcast studio kind of like I interact with my iPad and applications? So about half will say, yeah, that's really cool. I like that. That's modern. My kids will get it. And then the other half will say, oh my gosh, no way. I would never do that. I'm never going to abandon physical faders. You're out of your mind. And what's cool is that you can really do either one. It's not a requirement to go to a multi-touch console as a result of moving the console into software, but it is possible. And because it's enabled, because it's activated by this idea, we've been working on ways to make a software-based console more, as you were saying earlier, Kirk, maybe you can make some adjustments and put it away. Well, that's kind of hard to imagine if you imagine your hands on faders all the time. If you really imagine writing a show, then making adjustments and then gesturing the console out of the way so you can use the screen for something else, that doesn't seem right. That seems like it'll never work. But if we automate some things, if we actually use the power of software to pay attention to levels and perform some auto mixing and pay attention to what the other applications are doing, we may not need to ride the faders quite so much to run a radio show. And if that's the case, if we make our algorithms smarter and we're able to perhaps reduce the amount of operator interaction with the console, then yes, it might be possible to use a multi-touch console. So I just tossed that out there as a thing to think about. Some people will see me with a crystal clear or maybe our new Relay soft console, and they say, let me argue with you about why soft consoles are a bad idea. And I will say, no, I'm not going to argue with you because, we make physical consoles with physical faders too. We do both. This is not an argument that this one way is better than the other, but let's at least explore some new ways of doing business. Just like going back to the recording studio, there are some people who use software consoles in Pro Tools, and there are some people who use HUIs, human user interface consoles with Pro Tools. And it's a preference thing. So who am I to say which one is better?
Well, and that gives a perfect segue into our next sponsor. You're watching, by the way, or listening to This Week in Radio Tech, episode number 309. I'm Kirk Harnack, your host, along with Chris Tobin. Been my co-host for about 309 episodes. And our guest today is Michael Dosch, Michael Catfish Dosch. He is with Lawo, L-A-W-O. They are one of our sponsors as well. And we're talking about the idea of virtualizing a lot more in the radio station than the automation system. So we'll have more thoughts on that coming up. Our show is brought to you in part by the folks at Omnia and the Omnia 11. If you're a Facebook user, you've seen me make a couple of posts about how much I'm really enjoying playing with the Omnia 11 with new version 3.0 software and the new GeForce plugin and the perfect declipper. I don't know if the studio has ready the picture of an Omnia 11 handy, but if they there it is. Whoa, it's blue. It's different. Wow. Well, it's different in a lot of ways. The color is one way to certainly set it off. Let me, the folks at Omnia came out with a press release just today. Before we recorded this show. So while you're looking at that beautiful console and maybe not, the beautiful processor and maybe not me, we'll look at this press release. It was announced today that all Omnia 11 audio processors are now shipping standard with the new GeForce processing engine. Now, that was previewed at this year's NAB in April. Additionally, any Omnia 11 purchased in 2016 is eligible for a free GeForce license. That's usually almost $1,000 value there. That'll be available within 60 days as a downloadable field upgrade. Now, this upgrade will give current Omnia 11 users and customers a totally new Omnia processing engine. Now, those aren't just words on paper. I've been playing with this thing. It's a totally new Omnia processing engine without the added expense of a new box. So it's designed by the Telos Alliance CEO and Omnia founder Frank Foti and senior algorithm developer Cornelius Gould. GeForce represents a significant update to the Omnia 11's dynamics. They're so significant, in fact, that Omnia has given the display an all-new graphical user interface. I got to tell you, it sounds as good or better than it looks. Let me just spend the rest of my time talking about the Omnia 11 and telling you my impression. I have always understood that when you have to process audio for the FM transmission system, that you are going to have to do some things to that audio that we can mitigate. We can work hard to make them sound not irritating, but we're doing a lot of clipping. Of course, there's the pre-emphasis curve involved there, and Frank Foti years ago came up with a fantastic way to mitigate problems with clipping and pre-emphasis. And Cornelius Gould has added some of his thoughts into the Omnia 11 even before this 3.0 version came out. But I got to tell you, it's a whole new ballgame. So a couple of days ago, I got my Omnia 11 upgraded to 3.0 with GeForce and with the perfect declipper. Being an employee, they let me have at it a little bit sooner. And oh my goodness, I cranked up the audio and I do not hear anything that you would normally negatively associate with the FM transmission system and the preempsis curve and the clipping that you have to do. It sounds amazing. And I work for the company. Of course, I'm going to tell you good things about it. But my goodness, it is amazing. The best way I can describe how music sounds through the new Omnia 11 with 3.0 and GeForce is that it sounds the way that you, as an experienced listener, always hoped and thought a song ought to sound when it's processed, brightened, pumped up a little bit. I mean, the dynamics are there, the transients are there. The bass is amazing. Oh my goodness, Corny Gould just really understands how to get bass to work with transients to where you have this powerful feel. It sounds so natural, and it doesn't sound like what we've been used to on FM for years and years. That's about all I have time to tell you. I'm just so excited about this. Literally, I mean, okay, my jaw didn't drop actually to my lap, but after I got it hooked up and started listening to my favorite songs, and I'm a child of the 80s, man. I love 80s music, and I've started listening to some. My first call was to Corny Gould. Corny, holy cow, this sounds amazing. And he was very flattered at the compliments. He says, Kirk, we've been working on this for almost 4 years, and everything I know has gone into this. So anyway, there you go. Check it out. Call your nearest Omnia dealer. Get one of these things on order. You get the GeForce and the perfect declipper for free. And if you bought an Omnia 11 in 2016, you will get an upgrade to that. Just check it out. All right. Thanks to Omnia for sponsoring This Week in Radio Tech. All right, we are here at episode 309 with Chris Tobin, who is in some undisclosed location, as usual. He looks like... Chris, are you in a jail cell or what?
Yeah. Yeah.
You're up against a wall there, dude. Are there some engineers to the left and to the right of you with a height measurement we're picking you out from a lineup?
Yeah, there's a two-way mirror. Number 4, turn left. Turn right. Yeah. No, it's a voice booth. I'm in a recording studio here in New York at a friend's place.
Ma'am, is that the engineer who adjusted your microphone?
Is that the guy that claims you don't need a console? Are you sure?
Yes.
Is he the one that took it out?
No, the guy that claims you don't need a console is our guest.
Touchscreen? It's a point of sale screen. What are you talking about? It's a POS. No, it's POS Touch. It's fine. It can handle wet surfaces. It'll work just fine. So our guest is Michael Catfish Dosch with Lawo. And, you know, for over a year now, we've been advertising the crystal clear console and the touchscreen capability. And a lot of us, when we hear touchscreen, we think of difficulty and errors and touches that are in the wrong places. And did I touch it or not? Did it react or did it not react? Now, luckily, things like the Apple iPad have improved our experience with touchscreens. And and there are super duper professional touchscreens out there on the market that really do behave really well. And I think that the ones in the mid-range pricing are also doing a lot better. Catfish, you may have seen this yourself. There's a company, and I'm sorry I don't remember the name right now, but they're typically at the AES shows, and they're showing recording consoles that are huge touchscreens, and this company claims that they have improved the viability of touchscreen markedly by just making it super fast. You touch it, and it happens so fast. Yeah, it wasn't Stage Tech I'm thinking of. A company starts with an A, I think.
It's Slate, actually. And,
the
product is Raven.
There you go.
Yes.
There you go.
And yes. He's quite a character. I'm really impressed with Slate. I think that they have some very innovative products coming out.
And my point there wasn't so much to promote whoever it is, Slate's Raven, but just the fact that if you're an engineer like me and you're not convinced that a touchscreen can work for lots of things, then you need to experience a better touchscreen. And that kind of technology is out there, and it's available, and it's getting used.
It's a couple of things though with the touchscreen.
Mm-hmm.
It's more than just the physical touchscreen itself, whether it's capacitive or resistive. It's the application that's built and the graphics that are designed to work with the touchscreen. Part of the reason why the Apple products work as well is because the applications, as Catfish mentioned earlier, are designed to work with the touchscreen. I can tell you that many years ago, working with an automation system for commercial playout and other stuff, we discovered that the touchscreens we were buying, the $600 ones, wasn't necessary. We could actually buy the cheaper ones. What we discovered was that the application, the graphics, worked just fine as long as they were the size of, say, your thumb, if you're doing certain things, or your index finger. I can tell you that I've worked with many applications that claim to be touch capable, and the amount of space that it's using on the touch screen itself is not enough for your finger to properly touch without touching the next field. So if you're going into the world of touch screens and you want to do that stuff, make sure the application that's going to run on that screen is designed to work with a touch screen. So it's still have the human interface, even though you're touching that tabletop or the desktop, whatever you want to call it, the screen. You still need to have that part. And that's one of the impressive things about the Lawo product. I noticed looking at the touchscreen, the way the graphics are, it's obvious you guys made sure that you can touch exactly what the eye and hand coordination requires. And that's usually where things fall apart on touchscreens, when people complain that they don't work right. Because I've used some real dog touchscreens in emergencies, but the application I was working with, it worked just fine. The person using the screen could touch, do around, move around, do everything like you see my finger doing, and it worked just fine.
So Catfish, maybe that's a good topic to pivot to, and that is design, so that this stuff is actually usable. Because so many times touch screens are not usable because the software was not designed for it. It was imported to it.
Yes, I think that's a really good point. I think Chris is right on the money. If you take an application that has little tiny faders on it that you were using with a mouse, for example, you're moving the faders up and down with a mouse, and then all of a sudden you put that on a multi-touch capable screen. The first problem that you have is that the application might be written in such a way that it doesn't know how to deal with multiple mouse downs at the same time. That's actually just a fundamental problem. I mean, you can take a piece of software that was designed to maybe remote control a nice broadcast console and try to put that on a multi-touch screen, and all of a sudden it loses its mind when you try to do two things at one time. So that's fundamental. Chris mentioned the size of the touch targets, for example, and how you don't want to encroach on an adjacent touch target. Well, some of that actually can be written into the software. You can actually, and I know Apple does a lot of this, and other developers that are working with touch, they will pay attention to the center of the touch. So even though your big fat finger might flop over and be touching something adjacent, if the software is smart enough, it'll know that's just your big fat finger and you didn't really intend to touch the thing over there. And then finally, graphical design that pays attention to how big our big fat fingers are and make sure that it's comfortable to touch and to move. And then there's even yet another dynamic, which is think about a radio console. This is different than a recording console in that very often the guy that's on the air, he's maybe reading a piece of copy in front of him or interacting with his playout system, and he doesn't want to have to look down and figure out where his fingers are relative to the console. So he plays it by touch, just like you might with a computer keyboard or with a piano. You play it by touch, and this is an interesting challenge within the multi-touch environment. But it can be answered too if you're clever, and we can build die-cut overlays that your fingers are very sensitive to even the slightest edge. So you could have a die-cut overlay that shows that maybe it clears where the fader slot is. And now all of a sudden my finger kind of feels the edge and I know where it is. Or I could design it in such a way that maybe the edge of the screen or the edge of the monitor itself becomes kind of a physical anchor for my hands. Just like the bridge of a guitar might for a guitar player, and then I get used to the distance without having to look at it. So these are real human factor engineering issues, and we're working on them, and I know other people are working on them. The multi-touch device is not going to go away, so let's figure out how to use it in a way that's very productive.
What about do you call it haptic technology? What if you could have hairs or texture on the screen that are dynamically controllable? So one moment you've got the console on the screen, And as you mentioned, you have a die cut or cut out someplace where your finger knows where to ride. But then you change the application. You don't want some overlay to still be on the screen, limiting where you're going to want to touch. You want dynamic die cut, if you will. Possible?
Yeah, the die cut idea is pretty crude. And so yeah, if you were changing the screen and the knobs were moving and the controls were moving around, it would be a pretty lousy idea. Haptics, you mentioned haptics, and most people know something about haptics because at some point maybe they had a car touch screen that vibrated when they pushed a key, or maybe they had a smartphone that vibrated when they pushed a key, and it's pretty crude. At least the implementations that we've seen so far. It does give you some kind of tangible feedback, some kind of tactile feedback, but so far it hasn't been great. However, there is research that is actually in the military. They're doing quite a lot of research into some very exotic haptic technology that the surface of the screen actually is controllable. And it's crystal based, and the crystals are reorient depending on a particular field, and you'll feel edges. You'll feel, for example, a smooth area versus a textured area, and this becomes an interesting way to think about interacting. So we're at the computer technology is, and I think I've said this before, and I think it's really important. The computer industry and the IT industry, there's billions of dollars of research going into doing very interesting things. And in radio, we benefit when we try to adapt those ideas to what we do. When we try to invent everything from scratch, we end up bumping up against the fact that our industry is pretty small and we can't really spend the kind of R&D dollars that other industries can. But if you go back to AOIP, we were able to take an off-the-shelf Cisco switch, cost a couple $1,000s, and replace a $50,000 TDM router. And but we had to adapt it to our use. We had to take the technology that existed off the shelf and do some things in order to make it work for radio. And that actually is kind of what I'm talking about with virtualization. Here in the IT industry, we see all this virtualization going on. What can we do to adapt those ideas, that thinking, that technology to what we do in radio? And I think every time we do that, we make interesting products and we innovate.
Oh, we've been doing that for decades. And in fact, I was really curious about this haptic, because I thought I'd heard of beyond the military development of haptic or touchscreens, maybe with texture. It turns out that Bosch is doing this kind of thing. At the CES, they introduced something that they call NeoSense, and you can have different textures. Your finger senses different types of textures on the screen, and they had a demo. You could select a texture and feel it, and then you can also how these new, I haven't tried them myself, but I've heard a lot of description. These new Apple keyboards actually kick the key back at you a little bit because they depress so little that they actually provide a little kickback that makes you think that you've pressed it. And it's unbelievably effective. Actually, I have touched it once. Yeah, I have tried it on a touchpad. And they're thinking of doing the same. What if you had that same technology in a touchscreen where you thought you touched a button, your brain says you pushed that down, when in fact you didn't. The touchscreen just reacted to you. That has got to be where we can go with that kind of technology, and of course not just radio, but all kinds of things that we're used to. Having buttons now. Think of your telephone on your desk. Now you got key. You may have a screen on it, but you got keys and buttons and all that, because a touchscreen just doesn't offer the kind of feedback that your brain likes. But if you could have that thing kick back a little bit in the place that you touched, wow.
You bet.
Yeah.
So you're kind of singing my song here, Kirk. If we can move our products into software, then we can take advantage of all of these computer innovations. Or we could continue to try to build products that do things or we could try to duplicate what they're doing in the general computer and IT industries. But generally, we don't get great results when we do that. I'd like to talk just briefly, if it's okay, about virtualization bigger than what we've been talking about. We've been talking about, can I put my mixing console software on my playout computer? Can I put my codec and my phone system and my processor on my playout computer? And the answer is yes. But we don't have to stop there. We can actually, once we make these products into applications and we're running them on our playout computer, we can put them in other computers as well. We could take this whole idea and put it on a laptop. Laptops are very powerful these days. And now I could take my laptop and maybe a simple I/O device and make a portable radio studio. And in the laptop, we're running mixing, we're running processing, codec, phone system. For the talent that wants to work at home, or he broke his leg and he's in the hospital, he needs to broadcast from a temporary remote studio. You just make a temporary remote studio. You just take a laptop and an audio device and some mics and headphones and make yourself a radio studio. Again, we can do this because we're IP now. So, the connections back to the station for distribution, or maybe this is a podcaster and he builds a portable studio that he takes out on the road with him, and he actually does his broadcast, from this portable studio. Maybe he goes to Starbucks and makes a broadcast, or finds some free Wi-Fi someplace and makes a broadcast. So we can imagine new ways of doing things by imagining these software apps running in a portable environment like a laptop. We talked about the desktop environment, which is the typical playout software. We also could run these apps in a larger IT infrastructure kind of environment. Remember the server farm? Remember Amazon server farm? Well, that's a really interesting application where we've got these Intel servers. They're usually running some kind of hypervisor that hosts virtual machines, and then within these virtual machines, we could run these software applications. And so we actually could have these broadcast functions sitting in, quote unquote, the cloud, because they're running on these servers under hypervisors. And hypervisors are very interesting. I don't think we really have time to go into it, but these hypervisors that they use in the IT world are very broadcast. What am I looking for? The word I'm looking for here is they're featured for broadcast, even though they didn't build them for broadcast. They will pay attention to hardware failures, and they will automatically switch over to backup resources. You can clone a studio and run it on a different machine. You can centrally manage all kinds of resources. Imagine that you had the same studio for 400 radio stations all deployed. You could go and make one change in software, and it could replicate across your 400 radio stations without the local engineers having to deal with it. And so these hypervisors and these virtual machines running on this commodity hardware, this opens up a world of, a different way of doing things, a different way of actually building our broadcast plants. And quite frankly, I like Chris's term. He says you're only limited by your imagination, and I don't think we've even imagined all the things we can do. But if we take this second step, if we've taken the first step of moving our audio connections into IP, now we take the second step of moving our product functions into software. Then I think all kinds of imaginative ideas are going to come up, and we're going to dream of new architectures.
This notion you're talking about hypervisors and that how they can work with more sophisticated hardware to make you aware of problems that are going to occur or are occurring. We were entreated to Dave Turner from Enco a few weeks ago on this show, and he described Enco's Enco One product that does exactly this. It's got dual hardware everything in this server with a hypervisor that's made for it, and indeed it'll email the company and say, hey, this this chip is going bad, or you need to have a look at this power supply rail, and even to the point where it'll supposedly ship the part out to you so you can swap it out even while you're on the air. So yeah, the computers ain't what they used to be, and if you're not in that world of dealing with those kind of things, I didn't know about that until Dave mentioned it. So thank you for backing that up.
That absolutely doesn't surprise me coming from Enco. Dave and Gene, these guys were always dreaming about new ways of doing things, and so they're pushing the envelope. They're basically saying, here's this off-the-shelf technology. What can we do with it? The IT guys are having too much fun. What can we do in radio with this? I think it's great.
So, Chris and Catfish, we really hadn't talked about the last commercial in the show before the show. I have here in my hot hands the copy that I normally read and talk about, and sometimes I ad-lib a bit about the Lawo Crystal Clear. But since we have Mike Dosch here, Mike, would you like to talk for a couple of minutes about a Lawo product since you're sponsoring this part of the show, or would you like me to read the approved text? What's your pleasure?
You can read the approved text, but I'm really fond of the Crystal Clear. I think it's pretty fun. So yeah, let me talk about it for a minute.
Go ahead.
Crystal Clear. This will be off script because I have no idea what the marketing guy sent you. But I'll just talk about what I think is cool in the product. The Crystal Clear is a multi-touch based radio console. That's effectively it. I mean, it's got a lot of features and it's really cool. But what is Crystal Clear? It is a mixing console for radio that operates on a touch screen. So it's what we were talking about earlier. Some customers look at this and they say, this is exactly what I've been waiting for. And others say, no way, I need physical faders. Crystal Clear is the touch-based control surface. You would run it on, I guess what they call these 2-in-1 PCs these days, where generally there's a touch screen and it's integrated with a PC, or I guess they call them all-in-ones or 2-in-1s, and or you could run it on a desktop PC that has a touch screen attached to it. We generally like these all-in-ones. It's just very convenient, and so running this software, everything is presented to you on the screen. You've got meters, you've got clock, you've got timer, you've got on-off buttons, you've got faders. You can act, and we've tested this. You can run 10 faders up and down at the same time. You can change monitor levels. So all the controls that you would see on a typical 8-fader console, you're going to find them on this touch screen. Now the back end of this is a hardware-based engine. So you're running your user interface on the PC, and then you're connected via IP to your to a mix engine. And then that mix engine, it's a 1RU device, and it has all of the mixing resources, all of the DSP resources, and it has all of the audio I/O on this device. So really, with one rack unit device. And it's got some cool features like it runs Ravenna AOIP. It has redundant power capabilities. It can do AES, SDI. I'm not going to get into all the features of the product because quite frankly I can't remember them and I don't want to admit that. But you've got a one rack unit device, an Ethernet cable out to your touchscreen computer, and now you've got a radio console complete. So that's it. That's Crystal Clear, and you can pick up the high points that I missed, Kurt.
You hit most of them, except there's a guy in the U.S. That would like to hear from you. It's Bill Bennett at Lawo USA, and to find out more, you can of course you can go to lawo.com, LAWO, and you can call Bill Bennett at 888-810-4468. That's 888-810-4468. And Bill would be glad to tell you more about it. All right. Our show brought to you in part by the folks at Lawo. Thank you, Lawo, for sponsoring This Week in Radio Tech. All right, we're almost ready to close out, and I warned Chris and Catfish that we'd like to get a tip, and just to give them a moment more time, I would like to give you a tip of my own here, and to do that, I'm going to grab this camera, and I'm going to switch it around here and show you this is a PC that I keep running on my desk all the time, because I'm responsible for, boy, that's going to be hard to see, isn't it? That's just not going to automatically, there you go a little bit. This is showing ping times to 6 different locations around the world that yours truly is either interested in or responsible for. 2 of those ping times are, 3 of those graphs are for radio stations in my group in Mississippi, and one of them is American Samoa, the one that's got a lot of a lot of variation in performance. That's American Samoa, going by undersea cable or satellite, whatever the day happens to be. And then the bottom 2 are some servers that are in use by Telos for the Zip 1 product. So this product, this software is called Multiping by Pingman Tools. There's a free version, and then I've got the paid-for version because I'm really interested in it doing everything that it can do. So that's my tip, Multiping from Pingman Tools, and I absolutely love it. It's been running on that PC for literally years now, probably 5 years, because I was really interested in keeping track of these different servers and to find out, hey, are we having a problem at one of our radio stations because the internet is down? There's red lines when there's no ping returned. If you've got a bar that's 20 minutes long in time, guess what? Your internet was down for 20 minutes or something was down for 20 minutes. So that's my tip for y'all. Catfish, would you like to pass something along to our listeners?
I got nothing.
That's all right.
I'm sorry. I got nothing. I was trying to think of a cool website or something, but I'm drawing a blank here. So,
hey, you just did a 2-minute ad for your console, so that's probably a good tip right there as far as you're concerned.
Yeah, as far as I'm concerned, exactly. I'm biased.
That's right. Chris Tobin, you always have something that you drag up. I don't know where you get it, but what you got for us this week?
This week is real simple stuff. There's always the broadcast continuity or disaster planning or broadcast recovery. Radio station in a bag. There's a product out there on the market that might be handy. That's a good tip. You might want to invest in something like that and just keep it in the closet when you need to be on the road and get back on the air. But I'm not being biased about the source of that one, so you'll have to look that one up. Radio station in a bag. That's all
Radio station in a bag. Okay.
Yes. That's all. That's all I'm going to say.
I've heard of radio station in a box. I've never heard of jumbling it into a bag. That's
it's a bag. It's designed to be portable. Somebody else knows about it.
Okay.
But my tip.
Man,
What's
that
that?
was a great setup. Your check's in the mail, Chris, and that's at r3lay.com. That's relay, but E is a 3, so it's r3lay.com, and that's where you're going to find. It's on my it's underneath my face there. That's where you're going to find Lawo's Radio in the Bag.
Aha.
Yeah.
So there is
radio studio. On a laptop with an I/O device, and you throw some mics and headphones in the bag, and you go out in the field and make broadcast. It's pretty fun.
Is that paper or plastic?
It's a nice bag. It's
okay.
Backpack.
Cool. And we'll have that. I'm sorry, Chris. Go ahead.
There's something mentioned at PREC, so it was kind of
okay.
About.
All right.
But my tip for the day, I was just throwing that out there just to make sure that none of us, left the show without, with empty hands. My tip is I recently been using this Lucy app and happen to have a couple of friends who have radio stations with spare ports on their IP codecs at their transmitter site. And what I've been doing lately is when I get a call saying that somebody is off the air, I dial up their IP codec and I tune into their unit because it's listening to the mod monitor, so it's coming off the mod.
Yeah.
And I don't know if you can hear that. That's one of the radio stations. Oh, there we go.
Oh.
So when I get a call that they're off the air having a problem, I can go right to their over IP, listen to their mod monitor, and go, "No, you're on the air. Your monitor's not dead."
Good idea.
So that's my tip. It's free. Runs on an iPhone or an Android platform or Windows, and it's handy. It's just think about it. There's always opportunities. So that's my tip. And then there's that other one with that R3 leg. I'm not going to say anything more, but you know what I'm saying.
That's a great tip, and that's a good way to do it. One way that I've been implementing at my stations is kind of similar, kind of different, which is, with stream encoding being as easy as it is nowadays, I run stream encoders that now are confidence monitors. In other words, they're not for public dissemination because they're coming off a mod monitor. So it's not the audio. I mean, the stream encoder's fed by an off-air mod monitor. So you don't want to put that out to the public. It's not the greatest audio. You want audio that's processed for streaming. But if you want to check on something, I've got private streams of most of my stations that I can listen to. And I can say, no, you're on the air. If you're not hearing it, that's some other problem because you're on the air. So good idea.
See, that's where your imagination comes into play.
Cool. Hey, and we have a lot of that. Thank you all for joining us for This Week in Radio Tech. It's been episode number 309. Chris Tobin has been with us from some studio, a voice studio in the greater New York area. Chris, thank you for being with us. I sure appreciate it.
Oh, my pleasure. Always a fun time.
And then also Mike Dosch, Mike Catfish Dosch from Lawo has been with us. He's a director of virtual radio projects. So thanks a lot, Mike, for spending the time with us. I sure appreciate it.
My pleasure, Kirk. And by the way, I think you live 10 minutes away from me, so this is kind of weird.
I know. We should get lunch sometime. Hey, coming up on This Week in Radio Tech next week, I don't know, not sure. It's a War Stories episode, so we're going to try to dig up some war stories. But in 2 weeks, Mike Patton is going to be back with us, and the subject is RX, as in prescriptions, for TX, RX for TX. And that doesn't mean receive for transmit. It means prescriptions for transmitters. So Mike Patton will be with us in just a couple weeks. Also, we got a bunch of good shows coming up. Richard Hickey from Highlights is going to be with us about tower issues. So all that and more coming up. Thanks a lot to our sponsors. Thanks to Mike Dosch and Chris Tobin. And thanks to Suncast at the studio in New York City for making the whole show go. I really appreciate it. And thanks for getting us on Facebook Live, too. Appreciate that. Mark us on your calendar. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.